Assalamualaikum warahmatullahi wabarakatuh. My name is Alyasofea binti Nazrul Hisham with my partners Maizatul, Hudna, Nasuha binti Mazlan, and we are from College Jenis Insan, University Sains Islam Malaysia. And today we're presenting about optimizing urea uptake and release from hydrogel using FTIR analysis.
Our presentation consists of 4 main parts, which start with introduction, methodology, results and discussion, and lastly conclusion.
For the first introduction, the United Nations replaced its Millennium Development Goals with its Sustainable Development Goals to target ongoing development. On September 25, 2015, many United Nations member countries, among which was Malaysia, adopted these goals. This aim is to achieve a global transformation by 2013 by focusing on 17 goals.
SDG 2, Zero Hunger. End hunger, achieve food security and improve nutrition and promote sustainable agriculture. It is recognized that various concepts are interlinked. These include making agriculture sustainable, empowerment of small farmers, promotion of gender equality, abolition of poverty in rural areas, guarantees for a healthy lifestyle, and addressing climate change. The future trends of food security in Indonesia are alarming and threatening to our transition to new food developments.
In the agriculture sector, hydrogel technology is becoming more widespread. Hydrogel involves the use of water retention granules that grow to well beyond their initial size after coming into contact with water. Water can be both absorbed and released by agriculture use hydrogels, but the relative speed on this action depends on which hydrogel is utilized. Physical or chemical external stimuli affect the transition of the volume in which water is absorbed and released. Hydrogel can help in reducing through stress in agriculture. Therefore, its unique properties enable high porous hydrogel to be utilized as a plant growing medium, as it has the ability to hold water by swelling significantly. This eventually contributes to enhanced plant root oxygenation given its highly porous structure. Hence, hydrogel is widely utilized to absorb water and rainwater supply.
The objectives of our study is the first one to investigate the optimum condition of urea uptake in hydrogel, and the second one is to investigate the relationship between urea solution uptake and hydrogel structure.
Methodology part consists 4 subtopics, which is material, preparation of hydrogel, study on urea uptake, Fourier transform infrared FTIR analysis.
The first one is materials. SAP. The first one is materials. SAP, that stands for superabsorbent polymer hydrogel-based potassium polyacrylate in granular shape, were purchased from Zongma Chemicals. These hydrogels were obtained in a desiccated state, appearing as white in color. Meanwhile, urea used as nitrogen-based fertilizer was purchased from HMBG Chemicals. Additionally, the soil employed in the experiment of biodegradability test was acquired from a nearby local store.
Preparation of hydrogel. There is 2 different methods we employ to prepare the hydrogel. In the first method, superabsorbent polymer hydrogel granules were utilized in their dry form as received. In the second method, hydrogel was soaked in distilled water for a duration of 24 hours, resulting in a swollen hydrogel. Subsequently, the hydrogel was sliced into dimension of 1 cm before being utilized for a further experiment.
The preparation of urea solutions was conducted based on the specific conditions required for each solution. In all experiments, the initial weight of each hydrogel was measured before immersing them in their respective urea solution for a duration of 24 hours. Subsequently, the final weight of the hydrogel after immersing in different urea concentrations at various temperatures and pH levels was determined. The optimum uptake of urea solution by the hydrogel was calculated using equation 1. Following the immersing process, the hydrogels were stored in container until they were ready for further analysis and utilization. The equation 1 that is used for calculate the percentage of urea solution uptake, where WF is the final weight of hydrogel after immersed in urea solution, Wi is the initial weight of hydrogel before immersing, respectively. Simultaneously, a kinetic study was conducted utilizing the optimal concentration, temperature, and pH of the urea solution. The immersing time intervals were established as follows: 0.5, 1, 2, 3, 4, 5, 6, 12, 24, 36, 48, 72, 96, 120, 124, 144, 168, and lastly 192 hours. At each time interval, a hydrogel sample was extracted and the urea solution uptake for each withdrawn hydrogel was measured using equation 2 until equilibrium was attained. The kinetic of urea solution absorption in hydrogel data was fitted to the pseudo second order, where QE and QT are the urea solution absorbency of the product at equilibrium and time respectively. Meanwhile, K2 is the rate constant of the pseudo second order model expressed as in equation 2. Subsequently, the sample were removed from the urea solution, dried using filter paper, and weighed. Summaries of all samples was tabulated in table 1 and schematic diagram of the samples condition was shown in figure 1.
The functional group of SAP hydrogel before and after soak in urea solution were analyzed using an attenuated total reflectant Fourier transform infrared with a resolution of 1 cm in the wave number range of 4000 to 615 to analyze the functional group change during the process. Details analysis of FTIR spectrum was studied on the existence of nitrogen in the hydrogel at peaks 3,315 cm, 1,060 and 641 cm, respectively.
In results and discussion section, we will discuss about three main topics, which is the first one is effect of hydrogels preparation, second one is study of urea solution uptake performance, and the last one is kinetic study.
According to the figure 2a and figure 2b, show the preparation method of hydrogel before undergone urea solution uptake and different concentration for dry and swollen hydrogel and their physical appearance. As can be seen in figure 2b, when swollen hydrogen soak in urea solution, after the soaking period, urea crystals stay on the surface of hydrogel. This indicates the urea does not diffuse into the hydrogen structure.
Table 2 shows the urea solution uptake for both methods to prepare the hydrogels before further experiment at the same urea concentration of 15%. As compared to the method of preparing hydrogels, the ability of dry hydrogels to absorb urea solution is typically better compared to swollen hydrogels due to increased swelling capacity. Dry hydrogels have a higher capacity for swelling compared to already swollen hydrogels. This is because the internal structure of dry hydrogels is relatively unimpeded, allowing them to expand and absorb more liquid.
For the nitrogen existing, based on FTIR analysis, They will analyze the result by potassium polycrate gel, FTIR for hydrogel in urea from dry, and FTIR for hydrogel in urea swollen and urea crystal.
Table 2 shows the urea solution uptake for both methods to prepare the hydrogels before further experiment at the same urea concentration of 15%. As compared to the method of preparing hydrogels, the ability of dry hydrogels to absorb urea solution is typically better compared to swollen hydrogels due to increased swelling capacity. Dry hydrogels have a higher capacity for swelling compared to already swollen hydrogels. This is because the internal structure of dry hydrogels is relatively unimpeded, allowing them to expand and absorb more liquid.
For the study of urea uptake solution, the functional analysis was conducted to study the existence of nitrogen from urea solution diffused into the hydrogel structure. Figure 5 shows the FTIR spectrum of urea crystal and hydrogel soaked in urea solution at different concentration of urea. From the FTIR spectrum, it can be confirmed that urea has been penetrated into the hydrogel structure where urea peak at 3040 cm appeared in all hydrogel soaked in urea even though no peak existed in dry hydrogel with the same wave number. Peak at of 1200 cm which attribute to the C-N bonding in urea crystal also appear in swollen hydrogel, and higher urea concentration shows higher intensity of this peak.
Effect of temperature of urea solution. Investigation of urea solution uptake at different temperature has been conducted. However, it shows that urea solution at 40 degree and 60 degree has turned into urea crystals as can be seen in figure 6. Meanwhile, the swollen hydrogel in the solution also was covered with urea crystals at elevated temperature of 40 degree and 60 degree, and at the same time limits their swelling ability. This happened due to the urea solubility in water is highly temperature dependent. As the temperature increases, the amount of urea that can dissolve in water decreases. This decrease in solubility is due to the changes in the thermodynamic properties of the system, including changes in the enthalpy and entropy of the dissolution. At temperatures above a certain point, known as the solubility limit, the urea molecules are no longer able to stay in solution and begin to precipitate out as crystals. Therefore, at 40 and 60 degrees Celsius, the solubility of urea is lower compared to a lower temperature. As a result, if a urea solution is heated to 40 or 60 degrees Celsius, the concentration of urea in the solution can exceed its solubility limit, causing the excess of urea to crystallize and form solid particles or crystals.
For the effect of pH of urea concentration, pH 4 will get 469.96 urea solution uptake, pH 7 will get 803.667 urea solution uptake, and pH 9 will get 270.69 urea solution uptake. According to the kinetic study, the mass of hydrogel will be increasing between hours to hours. So, for the conclusion, a hydrogel should be absorbed at a rate of 45% of the concentration of urea solution. The hydrogel mass required to absorb the urea solution grows by 1 gram every hour. The temperature test revealed that room temperature of 24 Celsius resulted in a more effective hydrogel absorption process for the urea solution.
And that brings us to the end. I would like to say thank you for your time and attention.